Good morning, student. Welcome to TYBSc Analytical Chemistry lecture series. I am Dr. Kailas Labhade, Associate Professor, Department of Chemistry, S.VK.T College, Devlali Camp, Nasik. Dear student, today we are going to see gravimetry. It is the chapter from your analytical chemistry syllabus. In this lecture, we are going to see introduction of gravimetry, common ion effect, solubility and solubility product, co-precipitation and post-precipitation. Learning objective of this session. At the end of this session, students should able to understand what is gravimetry, what is common ion effect, what is solubility and what is solubility product, ionic product, solubility product and precipitation formation, and finally students should know what is co-precipitation and what is post-precipitation. Now let's start with analytical chemistry. Analytical chemistry is the branch of chemistry which deals with qualitative and quantitative analysis. Means in analytical chemistry, qualitative analysis as well as quantitative analysis is carried out. Now what is qualitative analysis? Qualitative analysis means detection or the identification of the species which are present in the sample. During FYBSc and SYBSc, we have done organic qualitative analysis as well as inorganic qualitative analysis. These are the example of qualitative analysis. Now another thing that is included in analytical chemistry, that is quantitative analysis. In quantitative analysis, measurement of actual amount of species which are present in sample that are determined. Now quantitative analysis is further classified into different groups. First group is volumetric analysis. It is also called titrimetric analysis. In volumetric analysis, measurement of the volume of the solution of known concentration which is required to react with analyte is measured. Another thing or another is instrumental analysis. In instrumental analysis, use of instrument for determination of unknown concentration of substance present in the sample is called instrumental analysis. AAS, that is atomic absorption spectroscopy, FES, flame emission spectroscopy. These are some important examples of instrumental analysis. Now third is gravimetric analysis. In gravimetric analysis, the sample is converted to precipitate, and from the weight of the precipitate, amount of the sample or element which is present is calculated. This is called gravimetric analysis. Now this is the definition of gravimetry. It is the process of isolation and weighing of an element or compound of an element in pure form as possible. Means in gravimetric analysis, element is converted to its precipitate. After precipitate formation, weight of that precipitate is measured, and finally calculation is done to find out the amount of element which is present in that sample. Concentration of analyte is determined by converting it into the product, and that product is nothing but the precipitate. Analyte is the species to be analyzed from the sample. Now here there are certain advantages of this gravimetric technique of analysis. It is simple technique. It requires minimum equipment. It is accurate technique. Analyte can be selectively converted to PPT. Means when there are more number of elements are present in the solution, one can selectively isolate one element in the form of the precipitate. These are advantages of gravimetric method of analysis. There are some disadvantages also. First, it is time consuming process because gravimetry involves different operation. There is precipitation formation, there is filtration, there is drying, and all these operations require long time. That's why it is time consuming process. And second, expert supervision or skilled operator is required for gravimetric analysis. Now these are some types of gravimetric analysis. First is called as precipitation gravimetry. In precipitation gravimetry, element to be analyzed is converted to suitable precipitate and weight of analyte precipitated is used for the analysis. Example, determination of Ag by precipitating at AgCl. Ag can combine with chloride and there is formation of AgCl precipitate. This precipitate can be separated, it can be dried, and after that its weight is recorded, and from the weight we can able to find out the amount of Ag which is present in that solution. Another technique of gravimetry is called as electrogravimetry. In electrogravimetry, the analyte is allowed to deposit as a solid material on electrode surface. Hence, there is electrolysis of the electrolyte is carried out, and after electrolysis, the element is deposited on particular electrode. After that, weight of the gain of the electrode is calculated, and from that we can able to measure how much element is present in that solution. Example, deposition of lead oxide at platinum anode, and another example, reduction of Cu2 plus to copper at platinum cathode. These are some example of electrogravimetry. Now operations involved in gravimetric analysis. In gravimetric analysis, there are different operations that are involved. First is precipitation. Suitable reagent is added to precipitate the element from the solution. This is called precipitation. Then digestion. After formation of precipitate, that precipitate is allowed to stand for 12 to 24 hours. Sometimes it is warm with mother liquor. That process is called as digestion process. Then third thing is filtration. Precipitate which is obtained is filtered by using suitable filtering media. Then washing of precipitate. Washing of precipitate is very important because selection of the solvent for washing is also important. For curdy and gelatinous precipitate, we use electrolyte solution for the washing. Then next operation is drying and ignition. After filtration, we require to dry that precipitate. If that precipitate is dried up to 250 degrees Celsius, then it is called drying operation. And if it is heated from 250 to 1200 degrees Celsius, then it is called ignition. Next operation is weighing. Dry precipitate is weighed to find out its weight. And finally, calculation. Calculation was done to find out the exact amount of element which is present in that precipitate. Here some reactions are shown. In this case, Ag plus that combined with Cl minus, and there is formation of AgCl as an precipitate. Second example, Pb2 plus combined with chloride ion, and there is formation of PbCl2 as an precipitate. Now for gravimetric analysis, common ion effect is very important. Common ion effect means to a weak electrolyte, when another electrolyte containing common ion is added, then degree of dissociation of weak electrolyte is suppressed. This is the definition of common ion effect. Another definition of common ion effect is extent of dissociation of weak electrolyte is suppressed by addition of another electrolyte containing common ion. This is the example which can use to explain what is the common ion effect. Now let's see. Consider weak electrolyte Ba. It dissociates as B plus and A minus. Dissociation constant of this salt can be write as K is equal to concentration of B plus into concentration of A minus divided by concentration of Ba. When another electrolyte containing A minus is added to above solution, it will increase the concentration of A minus in solution. Our initial salt, that is Ba, is containing B plus and A minus. Now if another electrolyte that also containing A minus is added, it dissociates, and because of that concentration of A minus in solution increases. In order to keep the value of dissociation constant K constant, some A that combine with B plus to produce undissociated Ba. Thus, there is decrease in dissociation of Ba. This is called common ion effect. This common ion effect can be explained by taking this example. In this example, let's see NH4OH is electrolyte. It dissociates as NH4 plus and OH minus. Dissociation constant of this base is given as NH4 concentration of NH4 plus into concentration of OH minus divided by concentration of NH4OH. Now if another electrolyte that containing common ion is added, say for example if NH4Cl is added, then NH4Cl is dissociate as NH4 plus and Cl minus. If you see these two reactions, in both of these reactions NH4 plus is common. That's why concentration of NH4 plus in solution increases. Now to keep the concentration of NH4 plus constant, some of NH4 plus can combine with Cl minus or OH minus to produce NH4OH. Hence, undissociated NH4OH is generated. Thus, degree of dissociation of NH4OH is suppressed or it is reduced. All these things we have already explained. Now let's see another example of common ion effect. Let's consider the example of acetic acid and sodium acetate. When acetic acid is dissociated, it produces H plus and acetate ion. As we know that acetic acid is weak electrolyte. Dissociation constant of this weak electrolyte is given as Ka is equal to concentration of H plus into concentration of acetate ion divided by concentration of acetic acid. You have to consider that Kb as Ka because acetic acid is acid. If another electrolyte, say for example sodium acetate, is added, now this sodium acetate and acetic acid containing acetate ion as a common. This sodium acetate dissociate to produce Na plus and acetate ion. Now because of this, concentration of acetate ion in solution increases. To keep the value of Ka constant, some of acetate ion combine with H plus and there is formation of undissociated acetic acid. Thus, degree of dissociation of acetic acid is suppressed. This is common ion effect. I repeat again, in common ion effect, to the solution of weak electrolyte, if another electrolyte containing common ion is added, then degree of dissociation of that electrolyte is suppressed. We have explained this concept by taking 2 or 3 examples. Now next point is solubility and solubility product. First of all, understand what is solubility. Solubility is the amount of substance that dissolved by a known weight of the solvent when substance is in equilibrium with solution. In other words, it is the ability of given solute to dissolve in a particular solvent at equilibrium at given temperature. This solubility is generally expressed in terms of gram per liter. Sometimes it is expressed in terms of mole per liter. Now, saturated solution and unsaturated solution and also supersaturated solution that also play an important role in gravimetric analysis. Now, what is saturated solution? When solution at equilibrium contain the maximum amount of concentration of solute is called saturated solution. Means at equilibrium, maximum amount of solute is dissolved in that solvent that solution is called as saturated solution. Now sparingly soluble salt, the substance which have very less solubility in that solvent, they are called as sparingly soluble salt. Generally 0.0 mole per liter is the solubility. If the substance have this much solubility, then you can call that substance as a sparingly soluble salt. In other words, they are just insoluble in that solvent or very less soluble in that solvent, and solubility is 0.01 mole per liter. For example, AgCl, Ag2CO3, PbBr2, BaSO4, all these are the sparingly soluble salt when they dissolve in water. Hence, their solubility in water is less than 0.01 mole per liter. Now solubility product. Solubility product in a saturated solution of sparingly soluble salt or electrolyte, the product of ionic concentration when raised to proper power is constant at a given temperature. It's called solubility product and it is denoted by Ksp. Now for explaining this concept of solubility product, let's consider the electrolyte Ba. Ba, when dissociate, it produces B plus and A minus. By applying the law of mass action, we can write equation for dissociation constant of Ba, and it is given as K is equal to concentration of B plus into concentration of A minus divided by concentration of Ba. As solubility of salt is very low, concentration of B plus and A minus is very low as compared to concentration of Ba. Here we are considering the sparingly soluble salt. We have already discussed that solubility of sparingly soluble salt is very less, that is it is 0.01 mole per liter. That's why concentration of ion B plus as well as ion A minus is very small as compared to concentration of Ba. Hence, concentration of Ba can be assumed as a constant. Hence, we can write the equation K is equal to concentration of B plus into concentration of A minus divided by K dash, where K dash is the concentration of Ba. By rearranging this equation, we can write above equation as K into K dash is equal to concentration of B plus into concentration of A minus. Now K into K dash is designed by another constant that is called Ksp. In another word, it is called solubility product. Ksp is equal to concentration of B plus into concentration of A minus. Now let's see another example for the solubility product. Here we are going to consider electrolyte AgCl. AgCl, when dissociate, it produces Ag plus ion and chloride ion. Applying the law of mass action, we can write K is equal to concentration of Ag plus into concentration of Cl minus divided by concentration of AgCl. As we know that it is sparingly soluble salt, that's why it dissociates partially, and concentration of Ag plus as well as concentration of Cl minus is very less as compared to concentration of AgCl. Hence, concentration of AgCl can be treated as a constant. Hence, we can write the equation K is equal to concentration of Ag plus into concentration of Cl minus, that is divided by K dash. K dash is the constant, that is concentration of Ba. K into K dash, that equal to concentration of Ag plus into concentration of Cl minus. Solubility product, that is Ksp, is equal to concentration of Ag plus into concentration of Cl minus. Now another term is ionic product. It is the product of ionic concentration in an unsaturated or saturated solution. That is the actual concentration of ions in solution. Solubility product and ionic product, these are two different things. In solubility product, we require saturated solution. In ionic product, that solution may be saturated or it may be unsaturated. Means any type of concentrated solution can be used to find out that ionic product. It is the product of ionic concentration in any type of solution. That is, actual concentration of ion gives the ionic product. For example, salt Ba dissociate as B plus and A minus, and ionic product of this salt is given as concentration of B plus into concentration of A minus. Now, what is the relation between ionic product and solubility product? This ionic product and solubility product are very important for formation of precipitate. When ionic product and solubility product both are equal, then that solution is called as saturated solution, and in that solution precipitate is not going to take place. Listen again, when ionic product is equal to solubility product, that solution is called as saturated solution, and in that case precipitation does not take place. When ionic product is less than solubility product, in that case that solution is termed as unsaturated solution. Once again, in that solution precipitation is not going to take place. When ionic product is greater than solubility product, in that case that solution is called as supersaturated solution, and in that solution precipitation can take place. I repeat again, when ionic product is equal to solubility product, no precipitate formation takes place. When ionic product is less than solubility product, in that case also no precipitation takes place. But when ionic product is greater than solubility product, in that case solution is supersaturated and precipitation formation takes place. Based on this discussion, we are going to solve numericals. First numerical, calculate solubility of BaSO4, barium sulfate, in water if solubility product is 1.41 into 10 raised to minus 10 mole per liter. In this case, solubility product is given and we have to find out solubility of BaSO4 in water. Now for this example, let's consider the solubility of BaSO4 in water. Say for example that solubility is X. We know that BaSO4 dissociate as Ba2 plus SO4 2 minus. If solubility of BaSO4 in water is considered as X, then concentration of Ba2 plus is X, as well as concentration of SO4 2 minus is also X. Ksp of this barium sulfate is equal to concentration of Ba2 plus into concentration of SO4 2 minus. Now concentration of Ba2 plus is X, SO4 2 minus is also X. That's why X into X, that is X square, is the solubility product. Now value of solubility product is given and it is 1.41 into 10 raised to minus 10. That's why Ksp is equal to X2, that equal to 1.41 into 10 raised to minus 10. If we take the square root of this figure, we get the answer X is equal to 1.187 into 10 raised to minus 5 mole per liter. Hence, we can able to find out solubility of the salt if solubility product is given. Solubility in gram per liter, that can also calculated 1.187 into 10 raised to minus 5 into the molecular weight of that barium sulfate. Answer is 2.76 into 10 raised to minus 3 gram per liter. Hence, that solubility in mole per liter as well as gram per liter can be calculated if solubility product of that salt is given. Now let's see another problem. Solubility of AgCl is 0.003 gram per liter. Calculate the solubility product. Molecular weight of AgCl is given and it is 143.5. Solubility of AgCl is 3 into 10 raised to 3 gram per liter. and its molecular weight is also given. Thus solubility in moles per liter can be calculated. 3 into 10 raised to minus 3, that is divided by 143.5, that is 2.09 into 10 raised to minus 5 mole per liter is the solubility of AgCl in that solvent. Now dissociation of AgCl take place at AgCl is equal to Ag plus Cl minus. 1 mole of AgCl gives 1 mole of Ag plus and 1 mole of Cl minus. The solubility product of AgCl is Ksp is equal to concentration of Ag plus into concentration of Cl minus. We have calculated this solubility of AgCl, hence 2.09 into 10 raised to minus 5 into concentration of Cl minus, that is also 2.09 into 10 raised to minus 5. If you do the calculation, you get the answer, that is 4.36 into 10 raised to minus 10. Hence, we can able to find out the problems, or we can find out the solution for the problems of solubility as well as solubility product. Now, for formation of good precipitate, there are some important conditions, and these conditions we are going to see here. First condition, precipitation should be carried out in dilute solution. To avoid contamination of precipitate or to minimize co-precipitation, we have to carry out the precipitation in dilute solution. Second, precipitation should be carried out in hot solution, because in hot condition maximum impurities are soluble in that solvent, that's why contamination is less. Hence precipitation should be carried out in hot solution. Then third one, reagent should be added slowly with constant stirring. Slow addition gives better crystal growth, and also occluded impurities that can be avoided. Hence reagent should be added slowly. Crystalline precipitate should be digested as long as possible to avoid co-precipitation. We already know what is the digestion. Digestion means allowing to stand that precipitate for 12 to 24 hours, or warming the precipitate with mother liquor, that is called digestion. If crystalline precipitate is there, you have to digest that precipitate for better result. Then precipitation should be washed with dilute solution of electrolyte, washed with water. Precipitate should be washed with dilute solution of electrolyte. Washing with water may cause peptization. Hence, suitable washing solvent is very important. We have already discussed for gelatinous and curdy precipitate, washing with electrolyte can be done. Next is to eliminate the contamination of precipitate with impurities, reprecipitation should be carried out. If we consider that our precipitate is contaminated, then we have to dissolve that precipitate in suitable solvent, and reprecipitation can be carried out. By using this reprecipitation technique, we can minimize the contamination of that precipitate. Precipitation from homogeneous solution is employed to prevent supersaturation. This is another thing, precipitation from homogeneous solution. We are going to see this in detail in next session. Now, purity of precipitate. Main aim of our gravimetry to produce a pure precipitate, and if your precipitate is pure, then we get better result. If precipitate is contaminated by impurities, then error may arise. Purity of precipitate can be explained by two ways, that is co-precipitation and post-precipitation. Now, co-precipitation, the contamination of precipitate by the substance which are soluble in mother liquor is termed as co-precipitation. The impurities which are soluble in mother liquor or solvent, they can cause co-precipitation. Co-precipitation cannot be removed by simple method. It causes error in analysis. Type of co-precipitation. First type is co-precipitation due to surface adsorption. Adsorption of impurities on the surface of main precipitate. This type is predominant in case of gelatinous precipitate. Means if your mother liquor or solvent containing some impurities, after formation of main precipitate, some other impurities can precipitate and they can stick on the surface of main precipitate. That is called co-precipitation due to surface adsorption. Now the example, calcium ion is adsorbed over magnesium sulfate, as calcium sulfate is less soluble than magnesium sulfate. Suppose your solvent or your mother liquor containing Mg2 plus, it also containing Ca2 plus, then Mg2 plus can combine with sulfate ion to produce MgSO4 precipitate. Ca2 plus, if it is present in the solution, that can also combine with SO4 minus and CaSO4 is get precipitated. This CaSO4 can stick on the surface of MgSO4, hence it is surface adsorption contamination, and this is called co-precipitation. Another type of co-precipitation is due to surface adsorption. This is another example, Ag plus and acetate, they combine to form silver acetate as a precipitate. Now if iodine is present, iodide ion is present in that solution, then Ag plus that can combine with A minus to produce that AgI precipitate. Now that silver acetate precipitate can be contaminated by silver iodide precipitate. This is called co-precipitation. I repeat again, in co-precipitation, the impurities which are soluble in mother liquor, they can be precipitated along with main precipitate. That is called co-precipitation. Another type of co-precipitation is co-precipitation due to formation of solid solution. It is also called occlusion. This precipitation is expected during building up of the precipitate. In this type of co-precipitation, impurities are trapped within the precipitate during rapid formation of that precipitate. Sometimes impurities diffuse from the precipitate and form solid solution. When crystal growth is too rapid, then there is no time for impurity to escape. That's why we have to use dilute solution. We have to add the reagent with slow speed to avoid all these things. Example of this type of co-precipitation, co-precipitation of barium chromate with barium sulfate, AgCl and AgBr, another BaSO4 and PbSO4, they can be precipitated. Now minimization of co-precipitation, how that co-precipitation can be minimized. First thing, solution used for precipitation should have minimum impurities. That is, if your mother liquor does not contain impurities, then there is no chance of co-precipitation. That's why you have to use pure solution for formation of precipitate. Precipitate should be dissolved in proper solvent and reprecipitation should be carried out. If we think that our precipitate is contaminated, then we have to dissolve that precipitate in suitable solvent, and reprecipitation of that precipitate can be carried out to avoid this contamination. Operation such as digestion and aging should be carried out. We have to allow that precipitate to stand for 10 to 24 hours, or we have to warm that solution, warm that PPT with mother liquor, and that is called as digestion. Use of organic solvent can reduce co-precipitation. Then washing a coagulated precipitate with a solution containing a volatile electrolyte that can be employed to minimize this co-precipitation. Then another thing that we can do, that is slow addition, proper stirring, proper temperature. All these things can be used to minimize co-precipitation. Now another type of precipitation, that is called as post-precipitation. After formation of main precipitate, this post-precipitation is there. The process in which precipitation of some component occur on the surface of main precipitate after its formation is called co-precipitation. Hence, in this technique, in this case, in this contamination, main precipitate is opted, and if it is remain in that mother liquor, then contaminant which is present in that solution also get precipitate, and due to that contamination of precipitate is observed. Precipitate on standing in contact with mother liquor become contaminated by the precipitate of an impurity on the top of the desired precipitate. Example, during the formation of calcium oxalate, magnesium oxalate can be formed afterwards. If Mg is present in solution, then magnesium oxalate can be formed. This is called post-precipitation. Minimization of post-precipitation. Filter the precipitate as soon as possible. When main precipitate is formed, we have to filter that precipitate as early as possible to minimize the post-precipitation. Then avoid digestion. We know that digestion is the process to allow to stand that precipitate for long time. If that precipitate remain in contact with that mother liquor, then there is chance of post-precipitation. Hence, we have to filter that precipitate as early as possible. Then another thing, impurities are converted in such form that it cannot be precipitate. Impurities should be converted to another form that these impurities should not take part in post-precipitation. Concentration of impurities kept as low as possible. This means that we have to use pure solvent as well as pure reagent for formation of precipitate. If all material, that is all reagent and solvent, they are pure, then there is no chance of post-precipitation. Here there are some point of difference between co-precipitation and post-precipitation. First point, co-precipitation is maximum at the time of formation of main precipitate. Means co-precipitation is simultaneous process. Post-precipitation, it is minimum or zero at the time of formation of main precipitate. Second point, contamination decreases if precipitate is left in contact with mother liquor. Means for minimizing co-precipitation, operation like digestion can be carried out. In post-precipitation, contamination increases if precipitate is left in contact with mother liquor, because post-precipitation is the precipitation which is occur after some time when our main precipitate remain in mother liquor for long time. Third point, contamination decreases with faster agitation of the solution, and in case of post-precipitation, contamination increases with faster agitation of solution. Now fourth point, in co-precipitation, the magnitude of contamination is usually small. This means that co-precipitation is usually small. In case of post-precipitation, it may be high. Fifth point, contamination decrease at higher temperature, and in post-precipitation, contamination take place faster at higher temperature. These are some points of difference between co-precipitation and post-precipitation. Now student assignment. On the basis of today's discussion, you have to write the answer of this question and send it to my Google Classroom. First question, what is gravimetry? You have to explain the process in detail. Second, explain common ion effect with example. You have to define common ion effect and explain this common ion effect with example. Third is define solubility product. And fourth is what is co-precipitation and what is post-precipitation. Summary of today's session. In this session, we have discussed gravimetry, type of gravimetry. We have discussed common ion effect. We have also discussed how common ion effect is important in gravimetric analysis. We have discussed solubility and solubility product. In that, we have discussed solubility product of sparingly soluble salt. We have discussed purity of precipitate. We have discussed co-precipitation and post-precipitation in detail.